Today, we're digging into a huge, real-world case study. We're looking at how Bloomberg rolled out AI coding tools to their entire engineering organization. And let me tell you, the lessons they learned are pretty fascinating and in some ways, completely the opposite of what you'd expect.
So right off the bat, their whole journey really boils down to two huge questions. First, how do you hand over incredibly powerful AI to 9,000 engineers without it just turning into absolute chaos? And second, what happens when you find out your brand new cutting-edge AI assistant is actually making it take longer to get code approved and merged?
Now, to get why this is such a big deal, you have to understand the scale here. We're not talking about some small startup playing around. This is an organization with more than 9,000 engineers, and almost all of them are software engineers. And they are all in on this stuff. They have over 500 people whose entire job is just working on AI products and research. So yeah, this is way more than just a side project. And the systems these engineers are responsible for, they're absolutely mission critical. We're talking about systems that handle over $600 billion in market technologies. The pressure to keep things stable and running is just immense.
On top of that, the technical complexity is just mind-boggling. They're running one of the biggest private networks on the entire planet and managing one of the largest JavaScript codebases anywhere. And that is the incredibly complex world they decided to introduce AI into.
So where did they even begin? Well, their journey started about 2 years ago, right when there was this massive explosion of new AI tools hitting the market. It was a pretty overwhelming landscape, to be honest.
You know, their first steps probably look familiar to a lot of us. At the very beginning, there were just way too many tools to even choose from. They had some quick early wins, engineers whipping up fast proof of concepts and simple one-off scripts. But then they hit a wall, a plateau. The minute they tried to apply these tools to their huge, complex legacy code bases, the productivity gains just fell off a cliff. The easy wins were officially over. And this is where things get interesting. This plateau led them to a really important realization. Instead of just using generic off-the-shelf AI tools, they figured out they needed to build their own highly specialized AI agents that were designed to solve their biggest, most specific problems, keeping the code base up to date and dealing with system outages.
So they came up with two main types of these agents. On one side, you've got what they call Uplift Agents. You can think of these as little proactive robots that are constantly scanning the code, looking for vulnerabilities or things that need upgrading, and then automatically creating the pull requests to fix them. And on the other side, you have the Incident Response Agents. These guys are reactive. When something breaks, they spring into action, analyzing the whole system like crazy to find the root cause of the problem.
But those Uplift agents, they ran into some real problems. First, it's actually really hard to be 100% sure an AI-generated patch is correct if your test suite isn't perfect. Second, the agents created a flood of new pull requests that humans had to review. And this led to a completely shocking discovery. The average time to actually merge a piece of code went up. It also forced a big mental shift for the engineers. They had to stop thinking about how to write the code for a fix and start thinking about what the final result should be. That's a totally different skill set.
The incident response agents, on the other hand, were a massive success. The biggest benefit was just pure speed, but maybe even more important was that they were totally unbiased. See, a human engineer in a crisis might think, oh, the problem is probably X because it was X last week. The AI doesn't have that bias. It looks at everything, the code, the system data, feature flags, everything, to find the actual cause, not just the one we suspect.
Okay, so with these agents starting to work, a new problem popped up. How do you prevent 9,000 engineers from all trying to build their own tools, wasting time and creating a mess? Their answer was to build a central platform, and they called it the paved path.
The whole philosophy behind this platform was beautifully simple. They wanted to make doing the right thing, like using approved AI models and following best practices, so incredibly easy that it just becomes the natural choice. And at the same time, make doing the wrong thing, like going rogue with unvetted tools, so difficult that nobody would bother.
And the platform has 4 main layers. First is a gateway, which basically points engineers to the best AI model for whatever problem they're trying to solve. Second, a tool discovery hub, so you can check if another team is already building the agent you need. Third, a standardized platform for actually building and deploying these tools, taking care of all the boring setup work. And finally, and this is key, they made it super easy to build a demo, but to move that demo into production, you have to go through really strict quality control.
Of course, you can build the most brilliant platform in the world, but it's totally useless if no one actually uses it. So that brings us to the human part of the story. How did they get thousands of people to actually adopt these new tools?
Their first strategy was pretty genius. They have this training program for new hires that's been around for 20 years. It's a well-oiled machine. They just baked all their AI coding best practices right into that existing program. So every single new engineer came into the company already knowing the new way of doing things, and they ended up becoming change agents on their teams, pushing back against old habits.
Second, they took advantage of a community system they've had for a decade called champs and guilds. These are basically just groups of people who are really passionate about a specific technology. They used this existing structure to kickstart an AI community, which let people learn from each other organically and stopped different teams from accidentally building the same things.
And the third program came from looking at their own data. Their metrics were showing that managers and team leads were adopting the new AI tools much slower than the individual engineers. So to fix that, they created special workshops just for leadership to give managers the tools and knowledge they needed to actually guide their teams in this new world.
So they've built these amazing agents, they have a solid platform, and they've figured out adoption. What was the single biggest lesson from all of this? Well, this is where we get to the new reality of what it means to be a software engineer.
And here's the most profound insight of all. The real impact of AI wasn't just about making people faster. It fundamentally changed the cost function of software engineering. You know, those basic economic trade-offs that managers make every single day about what's worth building, what's worth fixing, all of that was completely turned on its head.
Now, this doesn't mean everything just gets cheaper. It's more like it rebalances the whole equation. Some tasks, like writing boilerplate code or doing a simple data migration, become dramatically cheaper, almost free. But that, in turn, makes other kinds of work, like deep architectural planning, solving really complex problems, mentoring junior engineers, relatively much more expensive, and therefore much more valuable. And that leads us to the final, really deep question they're grappling with now. A question that, frankly, every single engineering company is going to have to face. If AI is completely changing the cost and the value of everything an engineer does, what does it even mean to be a high-quality engineer anymore? What are the skills that truly matter in this new world? That's definitely something to think about.